Hello everyone, this is Pre-Cal Lecture 4.8. We're going to solve exponential equations using logarithms. And you'll need your 4.8 notes. We'll go over the front and back of this one sheet. And we'll be using the calculator a little bit. Okay, so starting out at the top of the notes, when bases are the same, exponents can be set equal to solve. So this is what we were doing in the first semester. In solving an exponential equation, we wanted the bases to be the same, and then we could set the exponents equal to each other. So just to remind you how we did that, in our first example, let's say we have 3/4 to the x power is equal to 16 over 9. Well, I need to get those two bases to be the same. So let me work with that 16 over 9. I bet you I can get that into some version of 3/4. So we have 3/4 to the x is equal to, how about 4/3 all squared? All right, square root of 16 is 4, square root of 9 is 3. If we square 4/3, we get to 16 over 9. Now, you might remember our little trick. If I flip the fraction and change the sign of the exponent, I could get that 4/3 into a 3/4. So we have 3/4 to the x power is equal to 3/4 to the minus 2 power. So I flip the fraction, change the sign of the exponent. Now our bases are the same, and we can set exponents equal. So I can just say x is equal to -2, and I don't have to do anything else. We're good to go. So that's the way we used to do it, but that's a really hard way to do it. We're not going to do it that way anymore. We're just going to use the properties of logs to solve exponential equations. Okay, so let's go ahead and do several examples with this. Got a new erasing device here. Look at that thing. Doesn't mess around at all. All right, look at that thing. Holy Toledo. All right. So our next example in the notes, we're right here in the notes. We're going to solve for x. We've got 3 to the x minus 2 power is equal to 4 to the 2x plus 1 power. What I want to do is take the log of both sides. That's totally legal as long as you do it to both sides. So we've got log of 3 to the x minus 2 power is equal to log of 4 to the 2x plus 1 power. Now, using properties of logs, what can I do with these exponents? I'm sorry, it's so smeary. Let's try a different pen here, see if that improves. All right, so we can bring that x minus 2 out front. So we've got x minus 2 times log base 10 of 3 is equal to 2x plus 1, bringing that exponent out front, times log base 10 of 4. Now log base 10 of 3 is just a number. We'll just put it in our calculator. It's going to be a decimal. All right, log 3.477. So what I've got here is x minus 2 times 0.477. And then log base 4 is also just a number you can put in your calculator. Log base 10 of 4. So log 4.602. So we want to take it out at least 3 decimal places. Now we've just got a good old linear algebra equation. So I'm going to distribute the 0.477. 0.477x minus 2 times 0.477. So that would be 0.954. Equals then 2x times 0.602. That'd be 1.204x And then 1 times 0.602 plus 0.602. Now we're just going to combine like terms. All right, I'll subtract. Let's get all the x's over here to the left. So we subtract x's. I have negative 0.727x. And then we will add 0.954 to both sides. And that'd be 1.556. So x is going to be 1.556 divided by negative 0.727. And that's negative 2.14. And then you can plug that in here and check. Do those two equal each other? All right, and it does check out. All right, so pretty cool. Okay, pause the video if you need to, if you're still writing, and I will do some erasing. Okay, next example is 2 to the 2x minus 3 is equal to 5 to the negative x minus 1. Now, I would hate to try to get that into common bases. That'd be a pain in the caboose. But we can take logs of both sides. And I'm going to show you this method also works with natural logs. So we don't have to use log base 10. So this time, just for poops and grins, let's take the natural log of both sides. We've got the natural log of 2 to the 2x minus 3 is equal to the natural log of 5 to the negative x minus 1. Now I can make these exponents into a coefficient. So bring that 2x minus 3 out front times the natural log of 2. Bring the negative x minus 1 out front times the natural log of 5. Natural log of 2 is just a number. Let's see what that is. Natural log of 2, I believe, is 0.693. It is. So we've got 2x minus 1, 2x minus 3 times 0.693 is equal to negative x minus 1. And then the natural log of 5 is 1.609. Once again, now we're just talking about a linear algebra equation. So if we distribute the 0.693 across this parentheses, I'd have 1.386x minus 2.079 is equal to negative 1.61x. I guess it'd be 1.609x. Let's change that to 1.61. Negative 1.61x minus, oops, forgot the x, minus 1.61. Now let's add 1.61 to both sides and have all the x's on the left. That'd be 2.996x. And then we'll add 2.079 to both sides. And that's equal to, if we do that, we'd have 0.469. So x is going to be 0.469 over 2.996. And that is 0.1565. All right, pretty cool. Pretty cool way to solve for those exponents. And you can plug 0.1565 in here and check. All right, pause the video if you need to, and we will keep going on to the back page of our notes. so just going through our, I'll use the blank one here so you can see a little better. There we go. So on the back page, 4.8.2, when solving an equation made up of logarithms, we want to isolate the logs, convert into exponential form. I'll show you how to do that. I'm going to work a couple examples. We want to always check answers for extraneous roots. And let's go ahead and highlight that. Remember, you can't take the log of a negative. So if you end up doing that with one of your answers, it's an extraneous root. You can only take the log of positive numbers. Okay, let's work these two examples. So we got the log of 5x minus 1 equals 2 plus log of x minus 2. All right, let's isolate the logs to one side. So get logs on same side. That means I'm going to take that log of x minus 2, move it over to the left. So I've got log 5x minus 1 minus log x minus 2 equals 2. Now I can use the properties of logs to combine these all into one log, just like we did at the end in section 4.5, 4.6. Okay, so this is subtraction, so it will be division. We have log base 10 of 5x minus 1 over x minus 2 equals 2. Now I'm going to convert this to exponential. Log is base 10, so I've got 10 squared equals 5x minus 1 over x minus 2. We're going to convert to an exponential. After that, it's easy. What's 10 squared? It's 100. Now let's multiply both sides by x minus 2 to get rid of the fraction. So I've got 100 times x minus 2 equals 5x minus 1. 100x minus 200 equals 5x minus 1. Let's get the x's all to the left, so subtract 5x. I got 95x. Add 200 to both sides equals 199. So x is equal to 199 over 95. That's fine if that's how you want to leave the answer. You want to put that in your calculator and make it into a decimal. It's 2.095. And if you plug that into the original, it will check. They will equal each other. All right. Very good. Okay, pause if you need to, and we'll do our last problem of this lecture. Okay. So last one, you do need quite a bit of room for this one. This problem is a little bit more intense than any of your homework problems. So if you understand this one, you're in pretty good shape. We have natural log of x equals 1/2 natural log of 2x plus 5/2 plus 1/2 natural log of 2. Now what I want to do first is make these coefficients into exponents, because we're going to take all these natural logs and put them all together. Okay, we're going to build a log house or a log cabin. Okay, so I've got natural log of x is equal to the natural log of 2x plus 5 halves to the 1/2 plus the natural log of 2 to the 1/2. All I did was take that coefficient, make it into an exponent using properties of logs. Now this is plus, so I can combine those two with multiplication. So we have natural log of x is equal to the natural log of, I'm going to put the 2 first, so 2 times 2x plus 5 halves, all to the 1/2 power. Since these are both to the 1/2 power, I can just multiply them, put them to the 1/2 power. Let's distribute that too. Natural log of x is equal to the natural log of 4x plus 5 to the 1/2. Now I'm going to isolate the logs to the side. So I've got 0 is equal to natural log. Now anything to the 1/2 power is like taking the square root. I'm going to go ahead and write it that way. 4x plus 5 minus natural log of x. So I just took that natural log of x and moved it over here, so I'm subtracting. Now I'm going to combine these two. I have subtraction, so that would be division. Natural log of the square root of 4x plus 5 over x. Don't really need the bracket, but we'll put it. Okay, finally, we can convert to an exponential. So this is like saying e, remember natural log is base e to the 0 is equal to the square root of 4x plus 5 over x. We converted that log to an exponential. Well, what's anything to the 0 power? It is 1. Now let's multiply both sides by x. I'm going to bring this all the way up top. Multiply both sides by x. To get rid of that fraction, we have x is equal to the square root of 4x plus 5. Well, what did we do when we had a radical? What do we do to get rid of the radical? We're going to square both sides. X squared is equal to 4x plus 5. Now this might introduce an extraneous solution. We'll worry about that later. All right, now we have a quadratic equation because we squared both sides. What are we going to do? Set it equal to 0 and factor. Right? Doink, 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 doink. Got an x, x. How about minus 5 plus 1? You FOIL that back out. That'll give you this equation. So x is equal to -1 and 5. Now, the way you figure out if it's extraneous is, does one of these make an illegal, or in this case with logs, would it, make it where you can't take the log? Well, -1, I can't take the log of a negative. We plug -1 right in here to x, suddenly this entire equation doesn't work. So -1 is extraneous. However, 5 would work for everything. So the answer is 5. All right, the homework is worksheet 4.8. That does it for this lecture, and I will talk to you at lecture 4.9.